sample means. All right, so just again, quick recap. Note the two distributions we have here. For this distribution, we see that it is skewed right. It has a mean about right there. We'll say, we'll call that 75. And it's not normally distributed. This is household earnings in thousands of dollars, right? So this is a sample size of 1. For here, we have mean household earnings for sample sizes of 100. So basically 100 random data points from this distribution averaged made 1 data point over here. And we still have the same mean at about 75. We see that since they have the same scales, this one goes a whole lot higher on the y-axis counterpart. We also see that it's a lot more tightly bound, so the variability is a lot less. So by taking the sample size and increasing it from 1 to 100, we got something that not only is now normally distributed, but also has a much lower variability and is centered around the same mean. So that's pretty useful. So what does that tell us? Well, it tells us a lot of things. First of all, it tells us that if our sample mean is the mean of a simple random sample of size n drawn from a large enough population where the mean is mu and standard deviation is sigma, then the mean of our sampling distribution, x bar, is going to be equal to whatever the mean of the population, mu. So the statistic will equal, the mean of the statistics will be equal to the parameter. The standard deviation for the sampling distribution of x bar is going to be equal to whatever sigma was, but it's going to be divided by the square root of n. So over here, if our standard deviation was, say, well, I don't know what it was. It doesn't matter. The standard deviation for this would be that same value except divided by 10, because 10 would be the square root of 100, as long as the 10% condition is satisfied. Now, this is going to happen no matter what what shape the population distribution is going to take. We saw that in the first section of these notes. So this tells us what we learned from the first demonstration in that video, that if we have a normal distribution that is, if we have a distribution that is normal as our population distribution, then the mean for the sampling distribution and the standard deviation for the sampling distribution are going to equal those two values no matter how large or small the sample size is going to be. We saw that in our visualization, our sampling distribution, even when our n was 2, still gave us something that was normally distributed as long as the population distribution was normally distributed. What we learned from the second half of that is that if we increase the sample size, then we can take something that is not normally distributed. We can get a sampling distribution from that same data, just like we had here, as long as we increase the sample size to at least 30. Our visualization only let us go to 25, but we saw that if we went up to 25, we still got very close. So 30 is the rule that we just stick with. As long as we're over 30, we're usually going to be okay. What does that mean for you? Well, that means as long as you have a sample size that's over 30, and you know that your sample size is less than 10% of the population, whatever the population may be, you can make a sampling distribution, and the mean of that sampling distribution is going to be a very good estimate for the parameter of the population distribution, and you don't even have to know that much about the population. You don't have to know beforehand what the population mean is going to be. You don't have to know beforehand what the population standard deviation is going to be. You can essentially work your way backwards to find information about the population. You can find these parameters using the statistics. As long as the sample size is big enough, it doesn't matter. You're good to go. And I know this is a short video, but it's not a whole lot of information that is new. It's sort of building on the previous processes, so it's not that complicated. We'll see a lot of examples here in a little bit.